to be able to live and operate in space and do the science for Thomas's group over here to be able to accomplish the mission that we need to have. Next slide. I tell everybody, I said, you know, without comm and data and commanding and everything else going back and forth, we don't get the critical science data. We can't command the vehicles that keep our crew members safe and be able to get things done. And so there's a whole international group of antennas and ground stations and processing facilities that are going to be supporting this mission and providing critical capabilities to be able to conduct and monitor and collect the data on the hardware that we're going to be flying. That data is very, very important for us to learn from and then be able to apply to the next part of the mission. It's also very important to be able to collect the data from those science experiments that we'll be doing that Thomas will be talking about. And next slide. So we've got a lot to learn before we go figure out how to live and work and around the moon and on the moon. And all that will be helping us then to be able to further apply that learning, because it's going to be even tougher for us to be able to go live and operate on Mars. And so what's really great is that here I am with a team of folks that are going to help us go get there. And one of the most critical activities we have while we're doing it is to do our science. And so I'm going to hand over to Thomas Zurbuchen, who will be talking about the science we'll be doing on this mission and the importance of it.
Thanks so much, Kathy. And you, of course, talk about that solar array, and I'm reminded that in about a month, DART will hit a little asteroid out there, Didymos, and it's, of course, powered by the solar panel, just like that, again, developed by Space Tech, and we're using it for the science missions as well. You know, the word that both of you are using, that really is the key of my notes, is learning. Yes, we're exploring. Yes, we're doing science. Yes, we're building infrastructure, but we're learning. And what I want to talk about is the learning of science. And I could talk about the robotic missions, including the ones that have mapped the moon for, frankly, over a decade. Lunar Reconnaissance Orbiter, others that are there and have done amazing work. But I want to talk and kind of go back and look at human exploration. And the first image gives you my favorite picture of human exploration. If you hang out with me, you know that picture, which is a picture of, first slide, please, is a picture of Buzz Aldrin standing next to a science experiment, which is a little foil, an aluminum foil that's correcting the solar wind as it's coming down at about 400 kilometers per second from the backside. You see the shadow going forward. That, of course, was collected, brought back to Earth, and it's the kind of science that was done on Apollo. What is so important to me, and what the next slide shows, is that we're going to a moon that is very different than the moon we left with the Apollo program, because science doesn't stand still. We learn a lot of stuff about this moon, and here is just one of the indications of it. It's, of course, a measurement by the Moon Mineralogical Mapper on the Indian mission in 2009, and of course in a paper of 2018 that shows water resources. Two of the CubeSats that are launching with Artemis 1 will map that water at different ways. One using kind of epithermal neutrons, the other one using IR to go look at mapping those resources that are there. It's those resources, of course, that are really, unexpected, kind of in the picture of the moon that we had in the past. Another element that is so important in the science that is done is indicated on the next slide, please, where we see one of the researchers who has built an experiment, in this case with yeast, that is out there, and the yeast being actually primed to be very sensitive to the radiation that is there. You, of course, remember that the radiation away from the Earth, away from low Earth orbit, is different, the space radiation, than the one here, because, of course, there's a magnetic field that deflects a lot of the radiation that's coming down, and much of the radiation does not come up, right? Because the radiation, space radiation, is not coming through the Earth. So it's a lot more radiation as you go beyond that, the radiation our astronauts will, of course, experience as we go there. And it's those experiments, of course, 70% of the DNA of yeast is very similar to the Earth. So we can learn about this as we bring these back. There's not just these, there's other algae, other kind of biological agents that are up there for us to learn about radiation damage. The most important part, though, is indicated on the next slide, which is the future. And I want to tell you, when I think of this is an artistic image, of course, of an astronaut on the surface of the moon, and there she is, and lunar regolith is through her hand as she is there, and what we're thinking about, of course, is the lunar landers that perhaps supported that, the overall artificial intelligence, perhaps even a ground team on the ground that actually, with the enhanced comm that you just talked about, Kathy, will provide information that's there. So you say, well, that's nice, nice fantasies. No, that is what our decadal strategy of planetary science and astrobiology has told us to do. Precisely those kind of robotic human science that are prioritized for the first time by the national academies. And frankly, just last week, we listened to a presentation, all of us up here, kind of that decadal coming back with these priorities, and there's a lot to learn, but we're excited. And Artemis 1 is really the starting point of active learning of that human exploration and context of a moon, as I said, that is very different than the moon that we left the last time we were there many, many years ago when I was a little kid, and I don't have any recollection of that, and neither do most of people on Earth. So that's what we're going to do. Now, tell us about space tech, Prasanth.
Thanks, Thomas. Thanks, Thomas. It is a great honor to be here at the Kennedy Space Center for this historic launch. The Space Technology Mission Director, or Space Tech, as we go by, shares everyone's excitement for this mission, which is kicking off Artemis and many more robotic and human missions to come. We in Space Tech use our portfolio to develop technologies needed to go, land, live, and explore on the moon and Mars in collaboration with industry, academia, and other government agencies. One of these industry collaborations resulted in the technology that will be flying on Monday. First chart, please. Pennsylvania and California small businesses, Bally Ribbon Mills, and Advanced Applied Composites San Diego, led by NASA experts, developed a one-of-a-kind, robust, multifunctional material for the spacecraft heat shield. Here you see an image of the equipment weaving that material for use on the Orion space capsule. They worked with STMD or Space Tech to mature, test, and deliver this woven thermal protection material for Artemis 1. Next image, please. Lockheed Martin used the material for Orion's heat shield compression pads. Here's a close-up look of what that looks like. If you go to the next image, please. On various locations around the surface of the outside of the aeroshell, as well as to insulate and protect other parts of the spacecraft. These are just two examples of small businesses supporting our next steps in human exploration by implementing new technology. We also will work with industry to support technologies in the areas like excavation, construction, in situ resource utilization, and power for the moon and Mars. This past week, we announced awards for 3 companies to create prototypes for vertical solar array systems to provide continuous power near the moon's south pole. We're also working on approaches to develop power through ongoing fission surface power collaborations with the Department of Energy. This work will yield modular fission surface power systems designed for the moon, and we also plan for this technology to power our exploration on Mars in the future. Exploring Mars will require additional suite of new technologies. For instance, we recently announced a collaboration with the company Microchip Technology to develop a next-generation high-performance spaceflight computing processor. This processor will have 100 times the more computational capacity of current spaceflight computers and advanced fault tolerance, enabling the complex computations we need for future Mars missions and other places in the solar system. STMD is fostering technology to get humans to Mars and land on the surface. We're working with industry to mature nuclear propulsion technologies, which could provide the power and the speed we need to get crewed spacecraft to Mars in a shorter time frame. Once we arrive, landing on the order of 20 metric tons on Mars is also a challenge. Can we go to the next image, please? Our LARFTED mission will demonstrate an inflatable aeroshell technology that could help land crewed missions on Mars. It is slated for a launch in the beginning of November for a demonstration here at Earth. We're also demonstrating precision landing technologies like navigation Doppler LiDAR on the Moon under the Commercial Lunar Payload Services Initiative, or CLPS program. Across all our focus areas, CLPS flights will help us demonstrate the technologies that can be used on the Moon as well as Mars. A number of these technologies have already been started to be developed on the Perseverance rover and demonstrated. Precision landing capability when Perseverance landed, and currently right now on Mars, we're converting the carbon dioxide oxygen from the atmosphere to oxygen that we could use for either refueling our spacecraft or breathing for future human crews. In closing, I want to acknowledge and thank every individual, business, and supplier that is helping to make Artemis and beyond a reality. Together, we are charting the path to the Moon and Mars through thousands of businesses and hundreds of towns across this country that are part of this endeavor with us. Thank you.
Thanks, Prasann. And before we hand it over to Randy, we have a message from Jessica Watkins on the ISS.
Hi, I'm NASA astronaut Jessica Watkins on board the International Space Station, flying 260 miles above our planet. From here, we have a tremendous view of our planet. It gives us great perspective on Earth itself, but also on the amazing accomplishments humanity can achieve. The space station has been the place where we've learned what it takes to live and work in space and how to keep astronauts healthy for long periods of time. So many of the things we do on the space station are giving us the knowledge, technologies, and tools we need for Artemis missions to the Moon and for our human missions to Mars and beyond in the future. To me, exploration is about pushing the limits of what we're capable of. As someone with a background in planetary geology, I'm really looking forward to all the science we will conduct on the Moon. The samples we'll bring back, the knowledge we'll gain from understanding the lunar environment better than we ever have before. I'm also looking forward to the surprises, the things we'll find or learn that we don't know about yet. Our Moon to Mars exploration efforts are for everyone. We'll be watching the Artemis 1 launch from here on the space station along with all of you. Good luck to the Artemis team, the Space Launch System, and the Orion spacecraft.
Thanks, and now Randy, she's teed it up for you.
Well, there's a saying in the space business that you never want to be a speaker that follows the astronaut. And I'd like to say I have to kind of add to that. You never want to be the speaker following the astronaut that's speaking from space. But as representing the implementers and the operators of all the science and exploration efforts you've heard, this distinguished panel of NASA leaders discuss, NASA's Astronaut Corps has been involved every step of the way. Embedded in the programs and the directorates, we're there to share our spaceflight experience and expertise in the design and development of these spacecraft, because ultimately we represent the people and the humans that are beyond these vehicles that are going to be making these missions to the Moon and then ultimately onto Mars. And so a lot of the progress recently has been on the hardware, and certainly Artemis 1 being an uncrewed flight represents that hardware. But the human presence has been involved along the way, because that is the pathfinder for our next mission, which is Artemis 2, which will send humans out beyond low Earth orbit for the first time since 1972. And so everything we're doing with Artemis 1, we're looking at through the lens of what can we prove out and what can we demonstrate that'll buy down risk for the Artemis 2 crewed mission. Certainly, as Kathy Leaders mentioned, we're training our crews through Earthbound analogs, space analogs, as well as ones that are, taking the ISS, that incredible, space exploration test bed, and using that for analogs as well as testing hardware. One example of that hardware is the fact that we know that Artemis is the sister of Apollo, but the twin sister of the toilet is going to be on Artemis 2. That's over in the ONC, is up on the ISS right now, getting tested out and learning more about it before we actually fly it on the Artemis 2 mission. And so that's a great example of that. And so we have an incredibly diverse astronaut office and astronaut corps, in both terms of people and as from their experience. And we're able to harness all those skills and talents and wide variety of them, planetary geologist to military test pilot. That's just one example of, 2 people in the office. But we've got astrophysicists, we've got educators, we've got medical doctors, we've got engineers, of course, and even a veterinarian. And so we're using all those talents to be able to go out and do these exploration missions that are going to be taking place very soon on the moon and ultimately on Mars. So thank you.
Thanks, Randy. And now we want to hear from you all. So for folks in the room, if you have a question, if you could raise your hand. As a reminder for the folks on the phone, if you could please press *1 to get in the queue. And online, if you could use #Artemis. First up, Marcia Dunn with AP.
Marcia Dunn, AP for Mr. Free. I was hoping you could explain the 2-year lag between Artemis 1 and 2. What's driving that? And if this test flight goes really well, can you push up the next flight and make it sooner than 2024?
Yeah, so there's a couple. There's just the development of the vehicle. So the Orion crew module for Artemis 2 is fully outfitted with all the environmental control and life support systems that we need for the crew. So the development of that and the integration of it is complex and is one of the things that is driving the time between. The other is we're reusing our avionics boxes from Artemis 1 on Artemis 2. So we need to get the vehicle back. I talked about our objectives, getting the vehicle back, getting those boxes out, and retesting them. We have to send them back to the vendor to retest them, then getting them back and putting them in the crew module, and then putting everything else around it that needs to be installed, and getting the vehicle tested and ready to go to be delivered. So, and the stakes are really high for that mission. So we're going to take our time and do it right. So as Artemis 1 has slipped out, that's driven some of the Artemis 2 schedule as well. But those are the 3 things that link it. So can we pull, I'm sorry, the second part of your question, can we pull it up sooner? I think what I'd say is we're going to get through Artemis 1. We're going to learn a lot on Artemis 1. So I could not stand up here and say, hey, let's pull it in. We're going to take some time to go through the data we find on Artemis 1 mission. And, worst case is we might have to make a design change. But the best case is we're going to do the right thing to keep one of the folks down at the end of the table, they're safe when they fly on it. That'll be our most important thing. So I don't think we'll pull it in.
Thanks, Jim. Lauren Grush with Bloomberg.
Hi, Lauren Grush with Bloomberg. It's the first time I'm saying that. So you talked a lot about sustainability. I was wondering if you could be more specific about what sustainability looks like on the moon. Can we say that is a habitat, a base on the lunar surface? Ultimately, how do you envision people living and working on the moon?
Yeah, I'll start. Anybody else can add in there since I think I said sustainable more than anybody. It's really what I said. We want an infrastructure on the moon that we can rely on when we go. So you talked about habitats. There's other things on there that we need. We need landing pads. We need communication systems. We need distributed power. So it's not really just about, hey, we're going to go and stay and set ourselves up for 30 days. We want everyone to contribute to it, so commercial entities, international partners. So the sustainability is we can go, anybody else can go, and we can stay for longer durations. That's really how I think we look at the sustainable piece. We can't do it all ourselves.
Yes. People tend to think about the crewed piece of it, which is important, but we also, when we start looking at operating, it's how do you meld the crewed piece of it, and then what Thomas was saying, the uncrewed piece of it in some ways to optimize science and technology development that we are hoping to get done, and optimizing the use of the infrastructure up there for our missions and mission purposes.
I will also add to that, in space, what we'll plan to do is institute resource utilization as well, to live off the land in essence, so we can get a lot of consumables from the environment there in the soil or the water that we believe it's there. We will use that to create a sustainable future as well.
Chris Davenport with Washington Post.
So just to follow up on that, for whoever wants to take it, there's a lot of talk about the astronauts and the rockets, and that gets a lot of the attention. But things like distributed power and dealing with ISRU and regolith, all those problems, I just wonder, do you feel like you're investing enough in those programs to create the sustainable presence?
So I don't mind starting, and I think Prasan can probably talk about some of the other. From my perspective, we have to put our plans together now for what we need as we develop the architecture. So we need to put in our budgets today the surface habitation that was mentioned earlier. We need to put in the budget today the rovers that we need to get out and do the science. So that's why when we plan the Artemis missions, we're planning them kind of in, I'll say, in chunks. Right? We need to get this done so then we can put our budget plan together. And then what feeds those elements that we bring down are the technologies that are developed in STMD. So are we doing enough? I would say I'd love to be doing more, but we also have to be realistic with the development that we can take on, that we can do in partnership with other countries and other entities, and then how fast the technology can be built as well. So Prasan, I don't know if you want to follow on to that.
I would add, so we are making investments now. We have plans for all the various different types of technologies to develop so that we can have the infrastructure in place. Power, it starts with power. Power enables you to do everything. So we need to be able to have sustainable power on the surface. And I mentioned we awarded 3 contracts just last week to start to getting that capability. We're developing modular power systems, fission-based, that will also increase the amount of power. And with that, we have plans for doing a pilot plant for in-situ resource utilization, where we will excavate and process the regolith and or the water to get consumables that will be useful for us in the future for all our activities. And so we are laying the foundation for all the different systems that are needed, communications, for example, structural, advanced manufacturing to do autonomous structure building on the surface. So all these things we are making investments on. And sure, we'd always like to do more than with higher budgets, but we are starting that process now.
Also, if I could add to that, we're also thinking creatively about how to bring commercial entities in as bigger partners. So not just buy their technology, but think about buying power and some of those as services. So it's a range of options that are being considered.
Jeff Faust with Space News.
Hi, Jeff Faust, Space News. Question for the administrator. When you were in the Senate, you helped craft the NASA Authorization Act of 2010 that directed NASA to develop the SLS that's now sitting on the pad at 39B. That bill directed NASA to develop it by 2017, and it's now 2022. From your perspective, what sort of lessons can NASA take away from that extended development of SLS and apply them to future elements of this Moon to Mars architecture so we don't see similar delays in the future?
That legislation, now law, also directed the development of the commercial activities in space. And we have seen the extraordinary successful commercial crew, commercial cargo to orbit under Kathy's leadership. And the combination is what has been described to you today. Now, your essential question is, what do you do to stop there being cost overruns and overruns on time? I would simply say to you that space is hard, and you are developing new systems and new technologies, and it takes money and it takes time. Need you look any further than the extraordinary instrument we have 1 million miles from Earth, now taking pictures of the universe, looking back in time. So what we are doing in the future to try to stop some of these cost overruns We are simplifying the system. We are taking, for example, 16 contracts and combining them into one so that we have one area, that one contractor that is responsible for all the subs. We're implementing a program office for Moon to Mars so that we can have better coordination there. We're trying to do all of these things and at the same time do space. And the proof will be in the pudding. But right now, we're on the cusp of something that is pretty great. And it's been described to you from this panel, and you have been seeing it out there, and the hopes and dreams are on that pad, 39B, right now.
Next, we're going to take a question from the phone. Christopher Kokonos from Astronomy Magazine.
Yes, hi, thank you very much, and good luck on the launch. I do want to ask Administrator Nelson a question from sort of maybe the devil's advocate or critical side, and that has to do with the cadence of Artemis. And as you all know, Apollo had many, many more test flights of the Saturns and the different modules before even attempting a landing, and Artemis's cadence is much faster before landing in a rugged and thermally challenging polar environment. So I'm just wondering if the administrator can answer back to those who think Artemis cannot or should not move this fast and try to land on the third mission. What do you say to those who think the Artemis cadence is maybe too aggressive? Thank you, and good luck.
Thank you. It's two different times. That was 50 years ago. Look at the advance of technology. I have ultimate trust in these people up here to know exactly when we should launch, and that's why this is a test flight. And as Jim Free said, this thing's going to be stressed and tested in a way that we wouldn't put humans on this. That's the whole purpose of the test flight. He has three main objectives, one of which you can't test in a lab. You have to bring it back hot and fast to see if that heat shield is going to do what it's designed to do. So that's the difference of 50 years of technology and techniques and computing and all the advances that go into this. But when you get right down to it, spaceflight is risky business. And we accept the risk because there is great reward. To do less is to deny ourselves and our identity as the American character.
Irene Klotz with Aviation Week.
Thanks. Thank you. For Senator Nelson and anybody else who might want to chime in, what do you think at this point is the pacing item to get astronauts to Mars in the next 15 to 18 years?
The timetable was set by President Obama. He said 2033. Each successive administration has supported the program, and the realistic time now that I'm informed is late 2030s, maybe 2040. Would anybody like to pick up on that?
Yeah, I mean, I would just say the pacing items are environmental control and life support. We're doing testing on ISS to try and buy that down today. Radiation protection for the crew. Obviously, the effects are a lot different, as has been said, outside of low Earth orbit, and an entry, descent, and landing. I mean, we've landed. I'm probably going to get wrong, 1 metric ton, and we have to land like 15 to 20 to get humans down there. So, and those tests are much like things we can do them back on Earth, like lofted that Prasanth talked about. but that technology has to be developed. And I haven't even mentioned propulsion yet. But because everybody, that is the kind of everybody jumps to propulsion, but the three things I mentioned have to be solved as well. So to me, those are the pacing items. A lot of that work is happening on ISS today with funding out of our organization. For the life support system, there's radiation protection things going on, entry, descent, and landing. So those investments are starting now. But to me, those are the three that I would highlight outside of propulsion.
I think one of the things people don't think about is keeping the crew healthy, both physically and psychologically, for a 3-year tour, right? And when you think about it, it's why having these differential environments to be able to have crews be able to be on orbit, the International Space Station, land. We right now actually have the crew, as soon as they land, go do different activities to see what they can do after being on orbit and being under certain protocols, Irene, because if they land on Mars, they're going to have to do things when they land on Mars after this trip. And so, it's really, what's great about that mission is it's testing us on all fronts: human, technology, behavioral, and it's going to take us really advancing the state across everything, which is exactly what you want us to be doing.
Thanks, Kathy. Thanks, Jim. Next up, BBC France.
And Radio Canada, Frédéric Castel. Can you tell us, you underlined the importance of the objective to land on the moon. What is precisely the schedule once you have achieved this first mission successfully? What is the schedule when you don't have Starship, which has flown once? Thank you.
So, we to land on the moon, we have to have the systems will be tested on one. We have to have Starship, and we have to have our suits. We have a development plan, a contract with our human lander company, SpaceX, that has development milestones in it and technology development milestones that we work and we monitor with them along their development path. And our team understands the challenges that they have, and when they launch Starship, we'll be there with them, watching them develop the technologies that they need to. I don't want to lose sight of the fact that we also just awarded our spacesuits contract, which is just as important. Starship could be ready, and if our suits aren't ready, we're not going to land on the moon. And the inverse is the same. If our suits are ready and Starship isn't. But I will tell you that when you get beyond Artemis 3, and you start lining up Artemis 4 and 5, we have a lot of development to go through, and a lot of things have to come together for the mission. So we've got to get used to the fact that some things are going to go slow, some things are going to go on schedule, and some things are going to go fast. But they all have to come together ultimately in that mission. My confidence comes from the fact that we have a human lander team that is, I believe, the best people in the world to understand landing on the moon. And we've entrusted that role with them, and we have a contract to SpaceX to deliver it, and it's their job to deliver to the contract that we need.
Just can you tell us if 2025 remains realistic?
That's still our goal. That is still our goal. So I talked about SpaceX. We have those development milestones. We just awarded the suit contracts. Part of the way the contracts work for suits is we put task orders out. We August 5th, I think, got the first task order responses for exploration suits that have a schedule laid out in those. The team is trying to work with the contractor to put that task order in place, and we'll hear from them I'm sure in the coming month, pending what the next month looks like when we launch on Monday. But short term, we have our structure is the administrator talked about the Moon to Mars program office that we've been directed to put in place by Congress. But we have a org structure today that there's one person I can go point to and say, tell me how things are going on Artemis 3. And that person is tracking all the milestones that need to come together for that. We're still hopeful to make it there in 25.
Thanks, Jim. Marcia Smith, Space Policy Online.
Hi, my question is for Mr. Nelson and Bhavya. when you're talking about the big strategy, the Moon to Mars strategy, doing this in 18 years, I'm curious, how do you balance the interests of the people who just want to get to Mars and worry about getting stuck on the Moon, and those who really want to get stuck on the Moon because they think there's a lot of stuff to do there and they want a sustainable presence? How do you balance that? How do you come up with a cadence of missions that's affordable and politically saleable and all of that to satisfy both groups?
Go ahead, start.
So that's an awesome question, and that has been the tension throughout. And in fact, that's one reason we've kind of gone, from Moon to Mars to Moon. And this administration obviously supported the continuity of staying on course. I think what we have done is, and we are continuing to do, work with our industry partners, the international partners, to develop a series of objectives. In fact, about 50, and it's under, development and fine tuning. And those objectives emphasize both Moon and Mars as targets. They are well integrated, and they demonstrate how doing certain things on Moon help us get that extensibility to Mars. And that's kind of how we are striking that balance. It is never Moon or Mars. It has to be Moon on the way to Mars. Mars is the horizon goal. NASA's goal is to continue to push the horizons, and Mars is the horizon goal. I don't know, Senator Nelson, if you'd like to add, or Jim?
And that's the legacy of the Biden administration. They have not ramped it up another notch. It's not just to the Moon, it's to the Moon, then to Mars. And that's what has been explained to you today, and that's how we're going to continue. You heard some of the exciting stuff that they're doing in space tech in order to prepare us. Jim mentioned that propulsion is a key, because if we go at present propulsion, it takes such a long time to get there, and then the planets are out of alignment. You've got to stay on the surface for such a long time for the first flight. You get a faster propulsion, you can go there, stay a few weeks, and come back. So all of this is working together.
I want to thank you all for your time and your great questions. I think we're all buzzing a bit with excitement. I'm personally wearing green for go. But before we launch, we have some great coverage for you. Tune into NASA TV tomorrow for a countdown pre-launch status briefing at 9 a.m. Eastern. And then coverage begins at midnight tomorrow night with tanking, and we'll be live on our launch broadcast at 6:30 a.m. bright and early on Monday morning. So thank you again, and go Artemis.